So today we will see some methods which are common in C++ and other programming languages. They are getter and setter methods. Let us see how these things are implemented in Python, how we can do it. And I would like to spend little more time in going in depth on how things are happening underneath, though different documentation and books talk about this. So I thought I will spend some time today, and then tomorrow maybe we can do. I will give you some work, some assignment which you can do it offline. In case if you want me to be there during the lab, also we can do it. Or I will join in the initial 10 minutes, 10-15 minutes to clarify any doubts or explaining the problem, and then you can go on implementing it on your own. We don't need to spend time together in the class, but I will decide maybe based on your input as well as how things go tomorrow. Okay, today we have two sessions, right? Today, now, and then after 8 o'clock, 8 to 10. So we will try to spend a little more depth in details about what are the getter and setter methods in Python. So basically, we said that in Python, all the methods and attributes are all public, default. There is nothing called private or protected that we see in other languages, and in specific in C++ we see this very in detail. Now how does Python handle it? Though it is also a object oriented language and it is supposed to cater for all the requirements of designing a system which is safer in terms of not having access to some of those in private variables, attributes by mistake from others or by intent from other objects. So we need to protect it somehow, and then we don't have this kind of separate access permissions like what C++ gives. The intent, the reason why Python maybe went away from this kind of defining them separately and then access, providing the language definition for each of those specific cases, maybe because the philosophy of Python design itself is to make it simple, as simple as possible, and not too many keywords and key languages. When you look at the Python code, it's not so complex in terms of multiple keywords and then usages and different complex functionalities. If once you bring in something new like this, private or protected or public, then you have to define what happens when a project when an object when a particular method is private or a method is public but the variable is private, and how is it going to access. So it actually complicates the design, or moreover, not only the programming design, even the language definition becomes complex when you add more and more restrictions or conditions to define a language. So I'm not blaming C++, and it has grown much more. The common complaint that any developer has about C++ is it is too complex, it's too big, and it has grown even with the new definitions and new activities which are being added. New features have been added to the language, and it has become really huge. And no one can claim that I know C++ in depth, because since I started learning that in 1987 or 88, okay, 90, I think 1990. Okay, 1990, I had a initial exposure to that, and then from there onwards, 2011 and 2021, there are multiple versions of C++ has come, and what I knew earlier is not there, or it is much more now. Okay, the features are. But Python has been consistently very easy to follow and not too complex in terms of understanding the language. But there are so many libraries and method, third-party libraries which are there to simplify it. But language as such is not so complex, I would say, compared to a language like Java or C++. So let us now see that our basic design philosophy of Python is to make it simple. Then how do we make sure that the program that we write are robust enough that object-oriented programming and object-oriented methodology is followed? So that's the key uh, mm, thing that we are going to learn today. There are two references. One is this book, which I have been constantly referring to, and then there is one web link which I saw had a good overview, but I will caution you that this link has something about hidden names or the hidden attribute as a single parenthesis followed by the name, whereas actually it is a double no underscore under, okay, double under, okay. So there is some mistake I feel in terms of defining what is a hidden name in a class. Anyway, I will explain you when I explain the code, but be cautious about this link when you are reading through that, okay. But I would urge you to read this chapter about um, get etc attributes in the book, as well as this link also will be good, and there are plenty of materials always available. Now, I'm sure you are aware, when we have a class, there are two attributes, which is class attributes, which we saw there, and then what has been initialized inside a init or any other method with the which is receiving a self as an object. There are object attributes. So there are two types of attributes which are there inside. Now, how do we provide access to them? This is called get and set attributes. Basically, we are worried about the object attributes in particular. How do we protect them? Because all the methods and attributes that we define inside a class are public from the design perspective, the definition perspective, language definition perspective. So you are allowed to access any object attribute obj dot some attribute, whatever attribute you have defined. You can access it without any problem. That means there is no restriction on that. Now, still, how do we bring out the OOD into the design? So some object-oriented languages support private object attributes that can't be accessed directly from outside. Okay, programmers often need to write getter and setter methods to read and write the values of such private attributes. So in C++, what happens is we define private int I, okay, int private. Then what do we do? Public, we'll say, and then set attribute or something, and then we access this inside I private, and then whatever value is passed, we write into this. So we give a public access methods, which these access methods are public, and then we provide private attributes under the private qualifier, then we provide the access. So that's how we do it in C++. Now programmers often need to write we need to write the getter and setter methods specifically, and what happens is there is no uniformity in defining those setter and getter methods. So everyone will have a different way of calling the names, and there are different attributes are there, then how many methods you will have to access them. Maybe some part of the private attributes are accessed through some public methods, some other private attributes are accessed through some other public access methods. So many complexity come, and then how do we define them? There is no uniformity in terms of that, but the new language definition may have. But what I'm saying is, from the if you are using the normal getter and setter methods, there is no uniformity there. Now Python doesn't need getter or setters. No, normally we here also we can use it. Nobody is preventing you, but I'll tell you what is the difference between that. Because all attributes and methods are public. Only thing is, if you are expected to behave yourself means you can say that, okay, in case even if the attributes are public, do not access it directly, use the methods that I am giving you, okay, and then using that method you please access them, okay. You can always say that to the developers, and if they behave themselves then it's okay, otherwise we are still prone to problems. So if direct access to attributes makes you nervous, we can use this Pythonic way of doing it, which is a property, okay. This is a decorator, okay. I will talk about it maybe uh, when we meet again at 8 o'clock in more detail, but before that I want to give you some overview, then we will go into that details in the next session. So now we'll see how we can find some way to have some names attributes that we want to keep it private, okay, that we will see. Now suppose you are calling some attribute as a name, we can have a getter and setter method. Getter method is to get the attribute name, maybe we call it as get name. Setter method is set underscore name, we can call it as that, and then we will have using these methods we will try to access the attributes. Now let me show you a small program which is from the book reference 2. We know that we can have a init method, and then we are passing a name, and we don't want the name to be accessed by outsider, but we are calling it as a hidden name. But please remember, this hidden name doesn't mean that it is really hidden. We can always create an object of this duck, d1 equal to duck d1, and then I can always write hidden name. I can print it, okay. It's not really hidden, but at least if I am telling the user developer that always use the get name and set name to access the variable, do not write it directly, call this method to do that, get name, then I will return you the name, and then set name, I will call this with the new parameter, I will set it for you. So this is a agreement, a gentleman agreement between the developer and the class definition, whoever is defining the class. But nobody prevents you from avoiding this completely and then accessing it directly, either to read it or to write into it. So there is nothing called hidden here, everything is visible. Now if you really want to do that, we may do a way of this property. Now this is too early to come about, not talk about it, but let me tell you what is property. This is an object that whatever you are getting is an object of type property. So what is property? It's a class. Property is a class which accepts not only two parameters, it accepts actually four parameters. Now what I am doing is I am defining a new property for this class, because it is this whole thing is within the class, even this definition, and then I am naming it as name. Now name is nothing to do with this particular hidden name, but actually it is going to be using it, but this itself is an object of type property, okay. Now I am saying that going forward, now use this name only to use the hidden name, and I am going to insist that this whenever you use name, it is going to use get or name set name as a function to really access this variable, okay, hidden name variable. Now it will be little difficult to understand when I explain this. Now it's too early, let us just understand this one slide and then go to the implementation, and then I will show you with an example, okay. Now let us define these methods as property of the name attribute. So we are going to call this as a name attribute, okay, but actually what it means is it's a property object, okay. And I'm defining a property. Property is a class defined within in Python, and it gets takes 4 parameters, but I am giving you only 2 parameters here. First one is a getter, another one is setter. This two should be a function name which is defined inside the class, and I'm defining this also inside a class. Maybe the tab is not aligned. Okay, the new methods act as a normal getters and setters until that last line. Normally this is a thing, and this last line it defines the two methods as properties of the attribute called name. Now once this is defined in a class, these methods become defined as a property of a name. Okay, for a with a property name as a called name. The first argument to the property class is the getter method, then second is a setter method. We are passing a function pointers, function objects to the class. Now when we refer the name of any duck object going forward, okay, maybe with this is defined in the class. Now if you refer name, okay, we will be actually using the get name and set name. So suppose if I say d1 equal to duck some name I have given, then d1 dot name, if I say if I am accessing it, writing into it, what is happening is I am setting it, so this function will be called, and this function is setting the hidden name. So this name attribute refers to the hidden name inside the object. And then similarly, if I am print d1 dot name, I am trying to get the name value, then actually I will be calling this get name object, function object, which is returning the hidden name content. So we have given a new name to the hidden variable using this property class. Okay, so there is another way to define it using properties, but we will not go into that. I am going to explain you little more details about a simple way of defining another class and then go into the detail. Okay, before that, let me see if there are any questions here. Okay, now let us look at a solution. Okay, now let me take another example. This is from this link. I will okay, I will take it from here. Okay, now I'll go slow a little bit. We are defining a class init function as a keyword. So keyword should be like this. So I'm having a object attribute temperature, assigning this value which is coming in. If I don't get it, I am going to initialize to 0. I'm converting it to Fahrenheit. I'm accessing it using self. Again, the object directly, there are no getter setter methods. We are directly accessing the object attribute. Now let me show you some calling this very already I have a code, so let me show you that code rather than typing it. So this is the way to call it. We know that. Okay, so now there are no getter setter method. Directly we are calling the accessing the temperature, which is a object attribute here because it is with respect to self, it's not a class attribute. And then we are calling the method this, which is internally accessing that using the direct access. Okay, there are no getter setter methods here. Now how is it done? So let us though I have already explained it earlier, let us try to little go deeper into it. How is it accessing when you say temperature? Now as I mentioned, it will first look for a local object attribute, if not then class attribute. If you are redefined a class attribute as an object attribute, then it will access the object attribute only, otherwise it will go into the class attribute. So there is a separate dictionary maintained at the class level and at the object level. Now we want to access c1.temperature, then what happens is it tries to look for this temperature in the dictionary which is maintained for the object attributes of the class of this object. Okay, there will be a object specific dictionary maintained, and then we are going to look into the dictionary. So let me print that dictionary. Because there is only one object attribute defined in this class, we have this. Now if we had another method with another self dot something, that attribute would have got added to the dictionary. Maybe we'll see that. Now def method 1 self value. Now I am adding another attribute. Let me call it as value, or this I'll call it as value due equal to maybe 100. Now this dictionary still doesn't have that object attribute, though it is there. Unless this method is called somewhere, this attribute is not going to be getting created. So let me call this c1 dot method 1. Okay, I should not maybe I will write it here. Okay, so let me call this. Okay, now let us access this dictionary. Now since I called this method, that which in turn created a new object attribute within the object c1, and now the dictionary has an entry for value. So based on how you call, maybe some methods may be called, may not be called with respect to an object. So some of the attributes may be present, may not be present in an object, and that's why we need a dictionary specific to object, because normally in C++ we don't have this kind of a mechanism where all the attributes are defined. So once you create an object, all the attributes will be there in default. But if you actually, it's not good practice to do it, but unless you have a need that this attribute is needed only if this particular method is called, then only you need it, then you can always do it, because it is a saving of space memory for this object attribute. But it is not uniform across all objects. I may have another c2 object without this attribute in it, and the dictionary of that will be not having this. So that is the kind of the language specific feature we should remember when you are designing some classes and the attributes when you are defining it. So this adding the self wherever you want in each method is not actually, you should know that it is going to cause some disparity in terms of what are the attributes are going to be there in that class if you do this. Okay, so that we can keep it in mind. Now let me explain this one, okay, which is now whenever we assign or retrieve any object attribute like temperature here as shown in the above, Python searches it in the built-in dictionary and then getting it. So that's what I have already told you. So and then when we are calling this with this method, it is going to be returning that value. So that is nothing specific. Now let me try to tell you what it is. Now let us see. When it is same as what we are trying to do, we are trying to access the temperature with respect to object, which is same as C1 dictionary, and the key is temperature and assigning it. So we can in fact assign a new value to the object attribute temperature. Now because we have another one also, value is also there, so I can do that. Value, sorry, I can say 200. Okay, so we can do that, directly access it using the dictionary and then the passing the key. So effectively what we are doing, we have a free access to the object attribute, because we know the implementation of how the class is, the Python is searching for the object attribute inside an object or inside the class. So we are defeating the purpose of all these getter setter methods, and we start playing around directly with the internals of this, okay, which is not a good practices. In doing that, you are supposed to maybe write a setter method and setter getter method and then access it. But we are just, I'm just showing you what all the different ways of just avoiding or not following the object oriented programming philosophy and trying to do all that directly from wherever you want. Okay, so you are doing it directly by changing this. Okay, so this is to only show you how things are there implemented. Now let us try to bring in some discipline of defining a class properly. Okay, maybe even here, unless a programmer is disciplined, we cannot insist on the programmer calling these methods properly. Okay, they can still go ahead and call it outside. Now I'm going to bring out one more thing here, this double underscore temperature. Now let me explain what I am doing here. Okay, we are having the same class init function temperature, the same thing here. Instead of in the definition directly assigning the value, I'm going to call my own setter. Okay, I'm going to call this as a setter because it is going to set the value. I'm going to call it as a setter. Now I'm calling it as a set temperature, some function name. Just it doesn't matter. I could have called it as get underscore temp also. Need not be temperature. It's not nothing to do with the name and the name of the function and the name of the variable. It's only a coincidence. And just for clarity, I have written it. But you could have written as a get temp and set temp also. No issues. Now what we have done, we are getting the parameter value. I want to set it, but I want to bring in some discipline. I want to make the user follow some discipline. Okay. Now here what I'm doing is I'm only inside the function. I could have just written self dot underscore underscore temperature. I could have done it here. Nobody prevents me from writing it. Okay, let me write it equal to. This also could have been done. Okay, just saying that. But instead of that, I'm asking the calling the set method, which is passed the object default. So because you are calling it with the self, it will be passed as a first parameter, and then set temperature. Sorry, this function second parameter will be value is passed. So we are calling this function, which is doing a testing. Okay, whether the temperature value is below minus 273 degrees, which is not practically possible below this value. So I am not going to set it. I am going to raise an exception. Okay, I have not taught exception, but this is the way to accept, raise an exception. There are fixed exception objects which you can send it. Value error is one of them. You are creating a value error object, which is an exception object, and then you are raising it here. So in case if the value that you pass is below the normal agreeable temperature range, it is going to create an exception. Otherwise, I am setting it. Now, actually, what is the name of the attribute here? Name of the attribute is this, which is underscore underscore temperature. Now, this is a unique Python specific naming, wherein when you have a attribute name which is starting with a double underscore, it's hidden. It is hidden in the sense I cannot access it directly from outside. Now let me try to create an object of this and then demonstrate that. So let us do that. Now please stop me in case if I am going fast or you don't follow something. Now I hope you have understood this. We have a init function which is calling a set a setter method which is accepting the value which I am getting it from the init. I am passing it across, and then I am setting it if the value what is received is within the limit, but I am setting it into a variable which is double underscore temperature, which is a hidden name. So what I mean by hidden name, I will come to that. Now I am creating an object. Now let us follow through the path Celsius 50. Now it is going to call this init function, which is because I am creating an object which is, if I have an init, it will be called. So what is done? Object is created first and then passed here. Okay, it's not like a constructor, it's a initialization method after the object is created. So object is already created and passed as a self, and the parameter what is passed 50 is coming in, and then it is going to be passed to the method which is a setter method passing this value. So again this method is going to be passed the same object which is created. Still the value is not set yet. 50 is coming in and it is within not is not below minus 273 50, so it is going to get set here. So finally here the variable underscore temperature is set after this creation. Okay, creation and then initialization, one followed the other. Now what is that we are doing? C2 get temperature. I am going to call this method directly because it's another method, though I am calling it as a setter and getter. These two methods are like any other method of the class. There is no specific uniqueness of these methods. Only thing is, it is understandable that whoever is using my class, they are supposed to use these methods to set the temperature value and get the temperature value. That's the agreement, because they cannot anyway access the temperature underscore directly. I will tell you that. Now they will call get temperature. Somebody is calling get temperature. Now I should get this 50 which is set here, and then I am calling that C2 with respect to Fahrenheit, and 50 will be converted into something else. Okay, so we get the value 50 and then the converted value of Fahrenheit is coming. So this is very normal. All of you will be able to appreciate that. Now let me try to explain the hidden name, whatever is now supposed to be the hidden name. Now let us try to access this C2 underscore temperature directly, because this is a self dot underscore temperature, which is an object attribute. Can I call it directly? Now it says that Celsius object means object of type Celsius class has no attribute underscore temperature. So it knows that there is an attribute, so it is lying. Okay, this attribute error, the Python is lying here, saying that there is no attribute called this name, is 100% lie. It is there internally, but it says that no. Now how is it? Does it mean that the dictionary, okay, let us look at the dictionary of this object now. Does it have this name inside it or not? Because if it really has this name inside, though I have defined as self underscore this, then it should not give this error. Okay, otherwise they have to define it this error to come up with the error. But having a value like this is actually a difficult thing to implement. Okay, who is calling it, whether they are rightfully calling this or not, so there's a problem. So let us now try to print the dictionary of C2. Maybe third time I'm calling C2 underscore dict. Now let us try to see what is there in it. No, okay, I have to comment out this. This guy is not happy that I am calling it. Now see here, 3 dictionary is having this name. So now it is very obvious, it's not no secret, we can always find out. Okay, what is the name given to the hidden underscore temperature by Python? This is the name. Now you can reconstruct it, it's not very difficult. what it has done is it has added the name, class name, before the actual hidden name that you are given, and then it has put on underscore, because always users are not expected to define any variables, or even in C language you are not supposed to define any variable with the starting with the underscore, because it is implicitly, language does not prevent you from using it, but it is the tools internally to use it. They are given the freedom to use those names. Okay, even in C language, you are not, the developers are not expected to use these names, which are specifically for the tools. So this is a interpreter which is quietly changing the name of the attribute which the user wanted to hide it. Okay, the intent that I have put double quote means I want to hide this name. That means I should not allow anybody to access any object created with my class using this name. If I don't want anybody to use it, then internally the tool should not be maintaining a dictionary with the same name inside. Okay, they should do something else. This is what we call this name mangling. Okay, name mangling, which I explained it in C++ also, it is there. Name mangling is done to the attribute so that the actual name given by the user or developer, sorry, or designer, is not visible outside. So even if you happen to see the class definition, because it's open source, you can always see the class definitions of all the Python program, whatever you have, but still you cannot, you are not supposed to access it using the same name. Okay? Internally it is mangling it with this name. Anyway, you can find out using this. So in that case, I will be allowed to use it using this name. So let us try to, now having known that it is being, okay, it is being maintained like this. Okay, now did I, okay, I think I have given the name according to what they are. Oh, sorry, I should put double quote here. So now I should be able to print it. Okay, because the now it actually, I told you that Python is lying when I printed this. It's not lying because it doesn't know. It's a change. The interpreter has already changed the name of this object attribute into this name, okay, internally, and that is what it is maintaining in the dictionary also. So it's not lying. It doesn't find the value because they cannot put the code like that, like what or some of the car manufacturers did, German car manufacturers did, in terms of bluffing. When they had a emission check, they were really sending out some information that they made the engine to run in a different speed and then cheated the Euro standards emission checking. And then they know that okay, I'm talking about a car. There was some case which was very popular. I don't know any of you have heard about it. It happened some, I think maybe 6-7 years back, when one Europe car manufacturer um, purposefully, willfully hidden the information that their engines are ineffective, okay, by actually running them at a different speed or consuming different kind of mm, fuel, so that the emission that comes out of the engine is below the threshold of whatever the standards was expecting. So it was actually doing it in a different way, and then when it was on the road, it was free for all. It was trying to please the customer by consuming less fuel, by giving more mileage, but emission was not within the limits. It was giving, above the limit. So the engine has to run at a different speed and different RPM if it has to be very conscious about mileage, but not bothered about the emission. What carbon monoxide comes out, or what nitrogen or something, whatever comes out, it should not, they cannot go together. So they did some manipulation like that. So which is caught later on, and then they had to pay a huge fine for that, and they lost the credibility of the customers also. So so similar to that, Python is not doing anything illegal here. It is hiding the inside, storing it in a different name, and that's why you are saying that when you try to print it like this, it is giving an error. Okay, so I hope this is clear. Now what is the time? Okay, we have some 5 more minutes. Where is it? Let me take. I hope this is clear so far. So I think I already covered it. So let me take it out just for the sake of completeness. So we are now. Can I access write it? Okay, okay. We have not seen that writing into it. Yeah, there is. If you are able to read it, you can also write it. So let me do it here. Um, so 1,000. Maybe it's too bad to write that value, but it's okay. Now I'm writing into it without a setter method. It's allowed. It changed. Okay. So we are able to access it using the mangled name directly, and nobody stops you. Okay. Still, even if you have a getter setter method, nobody stops you from accessing it, and you know the secret how it is internally mangled. So you can always access it. Anybody can access the any of your object attributes. Anybody can do it. Okay. Now let me use the setter method to, okay, sorry, this is not allowed. Wait a minute. Now let us see what happens. I Let me try to use this. What did I do that? Underscore temperature. Um, how is it working? Let me print it. So can someone tell me what is happening here? I try to use C2 underscore temperature. Now let me print the dictionary. You see here, there is a new variable attribute which is added to the dictionary now using this. Can someone tell me what is happening? Okay, we have reached a 5 minute, 10 minutes break class time. Okay. Uh, can you come online and explain what is, how is it getting added? Okay, did you Google and find out, or you are already aware of it, Mukesh? I'm not hearing you. Uh, can you unmute? Are you speaking? I don't know. Mukesh? Okay, I don't know whether you have difficulty in talking from there. Okay, let us break now. We'll come back at 8 p.m. Right? Yeah, 8 p.m. We'll come back and then continue here. Any
Hello.
question? Yeah, go ahead.
Sir, basically, you need to check the underscope and double underscope. So I think you are making the mistake.
Uh, okay. In that case, single underscore.
So single underscope is a different thing, and a double underscope in different thing in Python.
Okay, but the double underscore, single underscore should. How is it accepting it? I didn't get it. Okay, anyway, I will study about this and then go back. But at least I think so far whatever I have mentioned is correct, right? Double underscore being hidden.
Yeah, it is. It is okay.
Yeah. So maybe I
But
should.
here, I think you are putting the single underscope. So you are not resetting the minus 300. Can you
Uh,
change your double underscope here?
Change it to double underscore. No, double
Yes.
underscore it will give error, right?
Hmm. Yes.
So my question was, okay, understand that protected is maybe that is a symbol for this, but how is it accepting as C2 underscore temperature as, because we have not defined it earlier, okay, anywhere, and then it is also adding into the dictionary. Okay, that's a little surprising to me. Okay, I need to read it. Maybe before the during the break, you can also go through that. I will also try to go through it and then see what is happening. Okay, so this is actually adding a new um, attribute. We are adding it to the dictionary, which is not even defined is in the method. Okay, within the class, it is outside the class. I am trying to do it. So this is a little surprising to me. In case if any of you know it, please you can always explain me after the break. Okay, when we meet at 8 p.m.